This is a pre-lecture video on the ADAS model for the course Global Business Economics. I'm David Frankel, a professor at Melbourne Business School. Let's begin. In a prior pre-lecture video, we studied the Aggregate Expenditure Model. That model takes prices as fixed. Accordingly, it cannot predict changes in inflation rates. This makes it relevant only to the short run, days or weeks at most. In contrast, the ADAS model allows prices to change. This lets it predict both output and inflation over the business cycle. Accordingly, it is relevant not only to the short run, but also to the medium and long run, months or even years. The model has two building blocks, the AS curve and the AD curve. We will consider each one in turn. The AS curve is a simplified version of the Phillips curve, in which inflation pi is the sum of two terms. The first is expected inflation, pi e. The second is a positive constant gamma times the output gap, the percentage by which actual output y exceeds potential output y star. The AS curve has two key properties. First, all else equal, a rise in output y leads to a rise in inflation pi. Second, if output y equals potential output y star, then inflation pi equals expected inflation pi e plus gamma times 0, which is just pi e. We can now draw the AS curve in a graph. Output y appears on the horizontal axis, while inflation pi is on the vertical one. The AS curve is upward sloping, since a rise in output y leads to a rise in inflation pi. Moreover, when output y equals potential output y star, inflation pi equals expected inflation pi e. Thus, the AS curve passes through the intersection of the potential output line y equals y star with the expected inflation line pi equals pi e. This completes our discussion of the AS curve. We now turn to the AD curve. Recall that the AS curve captures the positive effect of output on inflation. The AD curve captures the reverse effect. In particular, if inflation rises, the central bank, or CB for short, raises interest rates. The rise in interest rates causes output to decline. The AD curve captures this negative effect of inflation on output. More precisely, the AD curve is derived from the AE model that was mentioned at the beginning of this video. That model states that output y equals the product of two terms, m and a. The first term, m, is the multiplier. The multiplier is a function of tax rates and savings rates. The second term, A, is autonomous spending. Autonomous spending is falling in the real interest rate rho, which equals the nominal interest rate I minus the inflation rate pi. On the other hand, autonomous spending is rising in consumer and business sentiment, asset prices and wealth, government spending, and exports. It is convenient to write autonomous spending A as the difference between two terms, Z and C times rho. Rho is the real interest rate. C is a positive constant. And Z is the demand shock. It captures everything else that affects autonomous spending: sentiment, wealth, exports, and government spending. Assume, moreover, that the central bank follows a simple rule in which the real interest rate rho equals a positive constant A times output y plus a positive constant B times inflation pi. Why is the constant A positive? First, a fall in y leads to a rise in unemployment U by Okun's law. This in turn prompts the central bank to lower the real interest rate rho to stimulate the economy. Since a fall in output y leads to a fall in the real interest rate rho, the constant a must be positive. In summary, we have three equations. First, output y equals the multiplier m times autonomous spending a. Second, autonomous spending A equals the demand shock Z minus C times the real interest rate rho. And finally, rho equals A times output Y plus B times inflation pi. These equations are collected at the top of the new slide. We now combine them. We begin with equation 1. We then replace A with its expression from equation 2. We next replace rho with its expression from equation 3. Simplifying the result, we find that output y equals mz minus acmy minus bcm pi. We then move the term involving y from the right-hand side to the left. We obtain y plus acmy equals mz minus bcm pi. Next, we factor out the y. Finally, we divide both sides by the term in parentheses. In the result, output y is the difference between two terms. The first term is a ratio of positive constants times the demand shock z. The second term is another ratio of positive constants times inflation pi. This equation is the key takeaway from this slide. This key equation appears at the top of the new slide. By this equation, holding z fixed, a rise in inflation pi leads to a fall in output y. The graph of this relation is a downward sloping line. This line is the AD curve for the given value of z. Now suppose that a bad demand shock hits. Z falls. Since the coefficient multiplying z in the key equation is positive, a fall in z lowers output y for any given level of inflation pi. In graphical terms, the AD curve shifts to the left. We now combine the AD and AS curves in the same diagram. At every point in time, the economy lies at their intersection, depicted here as point P. We can say more about point P if we focus on the long-run equilibrium. In this equilibrium, the economy has settled down. Inflation and output are the same from one period to the next. Households and firms learn to predict inflation with perfect accuracy. That means that expected inflation equals actual inflation. Accordingly, we can replace pi e with pi in the equation for the AS curve. We obtain pi equals pi plus gamma times the output gap. Therefore, the output gap is 0. It follows that output y must equal potential output y star. Summarizing, in the long-run equilibrium, inflation pi equals expected inflation pi e, and output y equals potential output y star. We now depict this result in the diagram. First, since output equals potential output, point P must lie on the potential output line. And since inflation equals expected inflation, point P also lies on the expected inflation line. We have shown that in the long-run equilibrium, the economy is at the intersection of four lines: the AD curve, the AS curve, the potential output line, and the expected inflation line. But if all we want to do is to locate point P in the graph, we don't actually need to find all four lines. In fact, any two lines suffice for that purpose, since any two of the four lines must intersect at a unique point. It stands to reason that we should use the two lines that are the easiest to locate. Which lines are these? Well, The AS curve and the expected inflation line depend on inflationary expectations, which are endogenous. They are determined by the equilibrium. However, we don't know the equilibrium. That's what we're trying to figure out. In contrast, the AD curve and the potential output line do not depend on expectations. They are exogenous. Thus, we should rely on them. In summary, to find the long-run equilibrium, it suffices to find the intersection of the AD curve with the potential output line. We now illustrate the power of the AD-AS model by applying it to the most common type of recession, one that results from a bad demand shock. There are three main examples of such a shock. The first is a rise in pessimism among firms or households. The second is a large fall in asset values caused by a bursting property or stock market bubble. Two such examples are the 1929 stock market crash, which caused the Great Depression, and the bursting of a real estate bubble in the mid-2000s, which caused the global financial crisis. The final example of a bad demand shock is a large fall in demand for one's exports. This might be caused, for instance, by a slump in the economy of an important trading partner. It might also be caused by steep unilateral tariffs imposed on your country by such a partner. We now use the AD-AS model to analyze such a shock. Initially, the economy is in long-run equilibrium at point P. The bad shock then hits. Z falls. The decline in Z causes the AD curve to shift to the left as shown. The economy moves to point Q, the intersection of the AS curve with the new AD curve. Both inflation and output fall. A recession has begun. Households and firms then notice that inflation has fallen. This lowers their inflationary expectations. For simplicity, we assume that their new expected inflation equals the actual inflation that they observe at point Q. Since, moreover, the AS curve must always go through the intersection of the potential output line with the expected inflation line, the AS curve falls to AS1 prime as shown. This decline in the AS curve gives rise to a new equilibrium at point R. While inflation at point R is lower than at point Q, output is higher. A recovery has begun. But we're not done. People now notice that inflation has fallen further. This leads them to lower their expected inflation further as well, to point R. The process repeats. In the long run, the process stabilizes. Expected inflation catches up to actual inflation. But where is this long-run equilibrium located in the diagram? Well, as shown earlier, the long-run equilibrium is given by the intersection of the AD curve with the potential output line. Thus, the new long-run equilibrium must be at point S, where the new lower AD curve intersects the potential output line. Summarizing, a bad demand shock first moves the economy quickly to point Q. This initial phase involves declines in both inflation and output. As inflationary expectations fall, the economy then gradually travels down the AD2 curve until it reaches point S. During this recovery phase, inflation falls further, but output Y grows until it once again equals potential output. This concludes the GBE pre-lecture video on the AD-AS model. Thank you for watching.